All right, this is the basic. I'm going to talk about the basic logic of hypothesis tests so that you understand. And when I do hypothesis tests, after I check the conditions, which are important, but they can keep you from seeing the logic, the beautiful logic of the hypothesis test. So after I check the conditions, I follow these 3 steps and it helps me see. Here are the 3 steps. Okay, obviously, you start out with the ho-ha. Write your null and your alternative. You need a null and an alternative hypothesis, so write them. Step 2. 2 is the key. It's the key. You have to draw a null model. Whether it's a 1 prop, 2 prop, chi-square, any kind of hypothesis test you're doing is going to have some sort of null model. Okay? Draw the null model and label it. Then after you do that, and only after you do that, stop and think. A lot of times the conclusion will pop out at you. Then back it up with the calculations, get the p-value, and interpret it. Okay, that's the 3 steps, and here's what I mean. Okay, so suppose, let's just say, back in 2000, 30% of people liked butter. I don't know. Has this increased? Okay, that's what I want to know. Has it increased? So what I need to do is follow the 3 steps, but I want you to see the logic, so I'm not going to get bogged down in calculations, okay? But here's what I do. I think, okay, I need to do step 1. Ho-ha, null and alternative. Well, if back in 2000, 30% like butter, I'm just going to assume 30% still like butter, and there's my null hypothesis, that 30% still like butter. All right, I want to see, has it increased? That's what I'm going to try to prove. There's my ha. Let's see. Let's see if we can find out significant increase, greater than 0.3. Has the proportion of people that like butter gone up? Well, after the new news that came out that butter's not that bad, I have a feeling it's going to go up, but I don't know until I test my hypothesis. Step 1 is done. I did my ho-ha. Step 2 is the key. It's the null model. What do I mean by the null model? It's the model that's centered at your null hypothesis. So here's what you have to think. So I'm not getting into numbers. I'm not telling you about your sample. Just think of the logic. Okay? If 30%, notice my null model is saying, my null hypothesis is saying, I think 30% do. I'm going to go through all these calculations thinking that 30% of people still do like butter. And I'm going to believe that until I go, whoa, it has increased. But I'm going to think it hasn't first. So I go in and I say, if 30% of people do still like butter, and I go out and let me hide this for a second, 30% like butter, and I go take a sample, won't my sample, my p-hat, be somewhere near 0.30? And if I take another sample, won't most of the samples I take have p-hats somewhere near? Now notice what this is. My null model is a sampling distribution. So after you write your ho and you ha, you pretend in your mind, yes, 30%, let's pretend 30% do still like butter. And then imagine taking thousands and thousands of samples. Won't most of those sample statistics be somewhere near around 0.3? And the answer is yes. Most of my samples will be, my p-hats will be near 0.3. And what happens is, hopefully you remember this from sampling distributions, you end up getting this normal-ish model. That's your sampling distribution. And you do this calculation, and maybe it's, it's root PQ over N. I'm not going to go into that right now. But suppose you go and you calculate the standard deviation of your sampling distribution model is 5%. So you say, well, even if 30% of the people, even if 30% like butter, most of the time if I take a sample, the p-hat's going to be somewhere between 25 and 35%, right? So if I went out and took a sample and found out that my p-hat was 35%, I wouldn't be like, they've definitely gone up. Definitely more people like butter now, because this is how things just happen randomly. Like if I got 31%, I'd be like, yes, they love butter. You're not going to draw conclusions. Think about what you're looking for. You're looking for evidence. You're looking to say, oh, it's a trick coin, or ooh, it's a magic trick. You want to see something that was so unlikely to happen randomly if this were true. Well, this model, the null model, is the model that shows you how things would happen randomly if the null were true. So what you're looking for is something that was unlikely to happen randomly if the null were true. Which means if you get a p hat up here, 0.45, if you go out and you find out, 45 out of 100 of your sample, you get a p hat of 0.45, you're going to look, wow, that's up here. Here's my p hat. That's unlikely to have happened randomly. Here's how things would happen randomly. Most of the time it's going to be in here. This was unlikely to happen randomly if the null were true. So that's the step 2. You made your ho-ha null model. Step 3 is the thinking. That's what we're doing. After you draw your null model, think. What would surprise you? Looking at this model, 0.45 would surprise me. I don't even have to go through the calculation. I know that's wicked. It's 3 standard deviations above the mean. That's insane. That doesn't happen very often. I think there's strong evidence to say that more people like butter now. The logic is this. This is the logic, okay? It's saying, all right, you make your null an alternative. If you remember the whole p-value video. Make your null an alternative. You assume that this is still true, that 30% of people do still like butter. Then you make a null model. This is where all the p hats would land if 30% still like butter. Okay? So it would be around here if 30% still like butter. You go out and take a sample, and you find in your sample 45% like butter. And you go like this. Where would that... Whoa, that's very unlikely to happen randomly if the null were true. As a matter of fact, that's so unlikely to have happened randomly if the null were true that I don't think it was randomly happening with this true null. I think the null was false. I think that more people do like butter now. So the null model shows you what happens, not too much, whoa, out here, once you get beyond 2 standard deviations, that's unlikely, it's statistically significant because it was unlikely to happen randomly if the null were true. Okay, so that's the big step. It's the null model. Draw it, because if you see it, you go, okay, here's where I'm expecting my p-hats to land. Whoa, that p-hat's way out there. That was unlikely to just happen randomly. So unlikely to happen randomly, I don't think it was random. If I calculate, remember, if you remember your null model, your normal model, what's the likelihood of being above here? It's 0.025. Only about 2.5% of the time are you above that, right? So anything out there is definitely statistically significant, well, based on the context of the problem, but that's odd to happen. So you know your p-value there is very low. P-value 0.002 or 1 or something. Notice with a p-value this low, I reject the null. There's strong evidence that more people like butter now. That's how I'm going to do all the hypothesis tests in here. We're going to start with we're going to make a null and an alternative. Okay. After we do that, we're going to draw a null model that shows if the null was true, here's where I'm expecting to get my samples statistics to look like. This is what my p-hats should look like, somewhere near my mul. Or here's where all my x bars are going to be, somewhere near my null, my mu. Because that's what I'm expecting to happen if the null were true. And then I look at that model and I'm like, okay, did my p-hat or x bar fall in there? If it's way out here, I'm going to be like, dude, wow, reject the null, okay? If it's way down there, that's what we're doing. That's the logic. 3 steps, okay? Ho-ha, null model. Think about what that null model tells you, that sampling distribution, and then do your calculations. But understand what you're doing. You're not a robot. You're not a robot plugging things into formulas, spitting out p-values. You're not a function like data, your sample goes in and you go, p.05, p-value low, reject the null. That's ridiculous. You're a human being. understand what the null hypothesis is saying, understand what that null model is saying, okay? Then understand what your p-value is saying, and then everything will make sense, okay? Hopefully that's a little bit helpful. I'm going to do a couple examples. I'm hoping it'll clear it up, but that's the logic behind it. Good luck.